Well, in this section, we're going to talk about exponential and log equations. And the first set of equations that we're going to talk about solving are going to be exponential equations. And we're going to specifically focus on how to solve an exponential equation when they have the same base or like bases. Now, in order to follow this property or this idea, we're going to use this property here. It's a one-to-one property that basically says that if I have a base of some exponential function equal to that same base of a different exponential function, then we can just simply set their exponents equal to each other, which is a convenient use for us to be able to solve an equation when our variable is up in the exponential position. So the first one we're going to look at here says 3 to the 2x plus 1 is equal to 27. Now, in order for me to use this property, the bases on both sides of the equal sign have to be exactly the same. So, you need to recognize that although this is the base 3, I can rewrite 27 to be a base 3. And that's kind of the goal. So we're going to let this side of the equation, which is already written with a base and an exponent, guide me as to what I need to rewrite the opposite side or the other term to be in. So I'm going to rewrite this as 3 to the 2x plus 1 equals. So you're going to want to think, how can I rewrite 27 as a base of 3? So 3 raised to what power gives me 27? 3 to the third is equal to 27. Now that my bases are the same, I simply set their exponents equal to each other. 2x plus 1 is equal to 3, and I solve the equation from here. So I'm going to subtract 1 to the right-hand side, and I get 2x is equal to 2. Divide both sides by 2, and I find x is equal to 1. So that's using this one-to-one property. Let's try that again. Here I have the example e to the x plus 4 equals 1 over e to the 2x. So the left-hand side over here is already written as a base raised to some power, and I'm going to use that idea to be able to write the right-hand side as a base e. So we're going to take this e to the x plus 4. Now, in order to apply my one-to-one property, the bases on both sides of my equal sign need to be up in what I would call the numerator position. So I am going to use the negative exponent rule to rewrite this as e to the negative 2x. Remember that by changing the position of the base, it changes, position being from maybe denominator to numerator or vice versa. When I change the position of the base, it changes the sign of the exponent. So now I have these written in the same base, and we're just going to put their exponents equal to each other. X plus 4 is equal to negative 2x. So I'm going to add 2x to the right-hand side. That gives me 3x. And I'm going to subtract 4 to the right-hand side, if I said that right, so negative 4. Divide both sides by 3, and I get negative 4 thirds. And that right there is the solution to my problem.